A new satellite may help scientists more accurately forecast those strong geomagnetic storms that brought us the brilliant aurora displays in May. Let's talk about why this new satellite, GOES-U, is important and how a new instrument called a compact coronagraph could completely transform the way we predict space weather. GOES-U is the fourth and final satellite in the GOES-R series, which stands for Geostationary Operational Environmental Satellites, and they're the most advanced weather satellites the US has. They're stationed in geosynchronous orbit, which means that the speed that they orbit the Earth matches the Earth's rotation. So they're basically always at the same spot relative to the Earth. They're in geostationary orbit, which is a specific kind of geosynchronous orbit, which means they're located at the plane of the Earth's equator. They mostly view the Western Hemisphere, covering the west coast of Africa to New Zealand. This is the current GOES fleet and the area it covers. GOES-U will replace GOES-East, which is currently GOES-16. GOES-U will become GOES-19 once it's operational. The storage satellite you see here is a spare satellite in case one of the two primary GOES satellites, East or West, becomes non-operational. The GOES-R program is run through a joint NOAA and NASA office, so if you're wondering why I'm talking about a weather satellite, which Earth weather is not a specialty of mine, that is why. GOES-U will have some features that focus specifically on space weather that I am very excited about. These satellites provide advanced imagery of the Earth and its atmosphere, measurements of Earth's environments, mapping of lightning activity, monitoring of solar activity, wildfire activity, that sort of thing. They're really important. There are other things that are important too, developing new skills and keeping them sharp, for example. That's why I like Brilliant, the sponsor of this video. Brilliant helps you learn by doing, with thousands of interactive lessons in everything from math to engineering to data analysis. It helps you build a daily learning habit, which is important for building those skills and keeping them sharp. You learn to solve problems through developing critical thinking skills, not memorization, with hands-on problem solving developed by an award-winning team of teachers. It's a more effective way to learn than just watching lectures. One of the courses I really like is Exploring Data Visually, which allows you to build a foundation in data analysis. Not only can you learn how best to analyze data, but this course will also teach you how to parse and visualize massive data sets to be able to interpret them more easily. To try everything Brilliant has to offer for free for a full 30 days, visit brilliant.org/@Astra or click on the link in the description. You'll also get 20% off of an annual premium subscription. Now, back to GOES-U. All GOES-R satellites are equipped with the Advanced Baseline Imager, or ABI, that images the Earth. They scan the disk of the Earth every 10 minutes and have the ability to zoom in to track storms with 30-second updates. If you saw that awesome footage of the April total eclipse from space, that was GOES-16's ABI, which is the satellite that GOES-U is going to replace. When GOES-16 is retired, if it's still capable of generating data, it will be repurposed and possibly repositioned. For example, GOES-3 served for over 40 years, so they won't just deorbit a functioning satellite when it's replaced. The GOES-R satellites also have a geostationary lightning mapper, or GLM, which helps them detect and map lightning, whether it's cloud to cloud, within a cloud, or cloud to ground, over land, or the ocean. Studying lightning strikes helps weather forecasters predict the severity of storms because rapid increases in lightning activity often precede severe thunderstorms. This camera can take pictures of the Earth at 500 times per second to track lightning. The things I'm really excited about on GOES-U, though, as a space person, are the tools for monitoring the sun and solar weather. The spacecraft carries 7 total instruments, and 6 were included on other spacecraft, including some space weather tools. But the 7th will be the first operational compact coronagraph and will help scientists forecast space weather. Let's break down what this can do. The compact coronagraph, called CCOR, will help scientists detect and, more importantly, forecast coronal mass ejections, or CMEs. CMEs are often triggered by solar flares or violent explosions that are a release of radiation in the sun's magnetic field on the surface of the sun. These are often connected with sunspots, which are cooler, darker areas on the sun that produce solar activity. Now, as I mentioned, CMEs can occur as a result of these solar flares. CMEs are bubbles of charged plasma in the sun's magnetic field that are violently released into space. These energetic particles and magnetic field travel through the solar system away from the sun after they're ejected. When they interact with the Earth's magnetic field, that is what produces geomagnetic storms that can affect power grids, satellites, GPS, but it also produces the northern and southern lights. For more on that brilliant aurora display in May, what caused it, and why we're having all this solar weather right now, check out my video. The way a coronagraph works is that it basically blocks out the light from the sun's visible surface in order to better see the corona or the outer atmosphere. Think of how the sun looked during the total eclipse this year. Whether you were lucky enough to see it in person or you just saw photos, during totality you could see the visible corona when the moon fully blocked the sun in our sky because the corona is not washed out by the light of the sun. CCOR is revolutionary because of its small size, which means it can be paired with a satellite the size of a small school bus like GOES-U. The compact coronagraph is also revolutionary because it will provide continuous observations of the sun's outer atmosphere, so scientists will be able to directly study the area where these space weather events originate. Right now, we use the LASCO instrument on the SOHO orbiter. This is a joint venture between the ESA and NASA. The spacecraft was launched in 1995, and this is what gives us most of our information on CMEs and solar weather. LASCO is a great instrument, but it's not necessarily real-time data. It can take up to 8 hours to download that data, and it's not continuously monitoring the sun specifically for space weather. The satellite is also not in continuous communication with the Earth, so there can be large time gaps in the data that have to be filled in. For all these reasons and more, CCOR is a huge step up from what we have now. Scientists are hopeful that CCOR data will allow them to issue space weather watches up to 4 days in advance to tell us whether solar weather will hit the Earth and how strong the impact will be. It's basically all about getting more and better information. Strong geomagnetic storms can wreak havoc on many things, including electrical systems. Being able to accurately predict space weather events allows operators to take precautions regarding the power grid, like voltage reductions. This can prevent widespread damage to the power grid because of a solar storm. It's really important, especially when the sun is active, like it is right now, because we're at solar maximum. The biggest solar storm on record was the Carrington event in 1859. If this happened today, the infrastructure damage could be so bad that it could knock out power grids for months. So this kind of advance warning is really important. GOES-U was built by Lockheed Martin, and the spacecraft is scheduled for launch on June 25th at 5:16 p.m. Eastern Time on a SpaceX Falcon Heavy rocket. The mission was delayed by a few months because of a liquid oxygen leak in the center core of the Falcon Heavy, but that's been taken care of, and it looks like we are good to go for June. Once GOES-U launches, it will go through a lot of testing to make sure everything is working correctly and to calibrate all the instruments. It is expected to be operational in the spring of next year. While GOES-U is the last GOES-R satellite to launch, NOAA is already working on the next generation of weather satellites. The first geostationary weather satellite launched in 1975, and the current generation of GOES satellites will last into the 2030s. Next, NOAA will turn its focus to GeoXO, which will take the place of the GOES-R satellites starting in the 2030s, with launch of the first GeoXO satellite scheduled for 2032. And that is just about all I have to tell you about GOES-U, the GOES-R series of satellites, and this June 25th launch. Thanks for watching. I am Swapna Krishna, and this is Ad Astra.